Hello everyone, welcome to DKodeTree. Today let's solve LeetCode 680 Valid Palindrome 2. In general, a string or a number is called palindrome if it reads the same forwards as well as backwards. And this problem gives us a string as input, and we need to determine whether it can become a palindrome after deleting at most one character from it. This actually means that deleting a character is not mandatory. And if the string is already a palindrome like this one, then we can simply return true without making any deletions, since deleting 0 character still satisfies the condition. However, if the string is not already a palindrome like this one, then we must check whether removing exactly one character can make it a palindrome or not. In this case, removing the fourth character actually makes it a palindrome. But in general, how will we know which character to remove? The simplest way to think about this problem is in two steps. In step 1, check if the original string is a palindrome or not. If it is a palindrome, then we will simply return true. And if not, then we will move to the next step, in which we will try deleting each character one by one and check if the remaining string becomes a palindrome or not. This approach works, but it's quite expensive in terms of time complexity, because each deletion can take up to O of n time, and checking whether the resultant string is a palindrome or not will also take O of n time if done optimally. And since we repeat this for all the n characters, so the overall time complexity becomes quadratic in nature, that is O of n square. A better way to solve this problem is by using the two pointers technique and allowing one mismatch to be skipped. So here's how it works. So this is the input string. We will take two pointers, left and right. Left will start at index 0 and right will start at the last index. We will compare the characters at these two positions, and if they match, we will move both the pointers towards each other. That is, we will increment the left by 1 and decrement the right by 1 and continue comparing. But if they don't match and it's the first mismatch, then we can skip one of the two characters. So this gives us two possible cases. One is to skip the character at the left index, that is to increment the left by 1, and second is to skip the character at the right index, that is decrement the right by 1. So at this point we effectively have two strings to check. One where we skip the left character, so our effective string becomes this part. So we need to check whether the remaining string OPSPOTS is a palindrome or not. And the other where we skip the right character. So we need to check whether this part is a palindrome or not, which means the string TOPSPOT is a palindrome or not. If either of these two turns out to be a palindrome, then we can simply return true. So in the first case, after the first mismatch, we move the left pointer to the next element, that is we skip the character at the left, and in the second case, we skip the character at the right, so we decremented the right character by 1. Let's continue with the case 1. So in this case, left is pointing at O and right is pointing at S, which does not match. And this time, as it is not the first mismatch, that means it's definitely not a palindrome. Now we'll check the second case, where our left is at the element T and right is also at element T. So we'll continue our example. As both of these matches, so we'll move our left pointer by 1 and also we will decrement our right pointer by 1. This time also both left and right are pointing at the same element O, so we can keep moving our left and right pointers. So we'll increment left by 1 and decrement our right pointer also by 1. So now both the elements at left and right are P, so they match and we can keep moving. So now left comes to 3, right also reaches 3. And as both of them are at the same element, so it will definitely match and we can say that this is a palindrome. So this string turns out to be a palindrome and we can simply return true as our result. And if none of them is a palindrome, then obviously the result is false. The beauty of this approach is that we only traverse the string at most twice. So our time complexity is actually 2 into O of n, which simplifies to just O of n. Also, since we only use these two pointers and don't actually delete characters or create new strings, so the space complexity is just O of 1. So this is the optimal way to solve this problem. Now let's go ahead and code this up. As discussed, we will take two pointers, left and right. Left will be pointing at the 0th index and right will point at the last index, that is length of the string minus 1. Now we'll run a while loop with the condition left less than right. We are using less than condition here instead of less than equal to, because the case where both left and right will be pointing at the same index will definitely be a palindrome. So we don't need to check that explicitly, and left less than right will suffice our case. Now, once we are inside this loop, we will compare the element at the left with the element at the right. So on comparing, there can be two outcomes. One is the character at the left index does not match the character at the right index. That is, s of left not equal to s of right. And the other case is both are same. So if both the characters are same, we will simply increment our left pointer by 1 and decrement our right pointer by 1. But if they are different and it's the first mismatch, then we will check whether the two strings that we formed by skipping either the left element or the right element are palindromes or not. So for this, here let's take a helper function and name it is palindrome. This function will take two indices as input, that is left and right, and it will return a boolean as result. So we'll implement this in a while. Now let's continue with our current loop. So the first time when this if condition satisfies, that is, if the left element is not equal to the right element, then we'll simply go ahead and return is palindrome of left plus 1 comma right, or is palindrome of left comma right minus 1. So this is the case where we are skipping the character at the left element, and this is the case where we are skipping the character at the right element. We are using OR here, so if any of these two returns true, then our result will be true. This expression will only run during the first mismatch, because the first time when this condition satisfies, the control will come to this expression, and whatever Boolean value it evaluates to, it will be directly returned. Also, we don't need this else condition explicitly here, because if we haven't entered this if condition and we have not returned anything, that means we can simply go ahead and increment our left and decrement our right. Now once we are out of the while loop, that implies that we have normally completed the while execution and both the left and right are at the same index, so we can simply return true as our result. So now let's quickly implement the isPalindrome helper function. Here also we will use a similar while loop with the condition left less than right, but in this case, if the element at the left does not match the element at the right, then we will simply return false, because we have already handled the first mismatch outside, and after this if any other mismatch happens, then it's definitely not a palindrome as per our problem statement. Otherwise, we will simply increment our left pointer by 1 and decrement our right pointer by 1. Now if the while loop of the helper function executes completely without returning anything, that implies that obviously this is a palindrome and we can return true. Note that even though inside the helper function we are using a while loop and the helper function itself is being called inside another while loop, still the time complexity is linear. The reason is that the part of the string that the helper function is covering is actually the section which is not covered by the outer while loop yet. Therefore, ultimately the entire string is covered at most twice. This is the reason that even though we are using a nested while loop kind of structure, still the time complexity is just O of n. Now let's run this. We can see that this is accepted and is efficient both in terms of time and space complexity. I have added the different solutions for this problem on my website DKodeTree.com. Feel free to check it out. If you found this helpful, do hit the like button and subscribe to DKodeTree for more such videos. Thanks for watching and see you in the next one.